All right, the purpose of this video is to look at the electrical systems in a Lithionics powered Jayco Terrain or Entegra Launch. The Lithionics system pairs with a Victron system for electrical control, and the two screens that you see here kind of operate all of it. So the upper screen is the Firefly, and the upper screen is really the main user interface for the van. All of the lighting controls, water pump, that kind of thing. And then the lower screen is more about the electrical controls, specifically around the inverter, charger, and how that operates. The battery, the Firefly, and the Victron system all communicate together over an RVC bus. That's a communications bus that's a variant of the CAN bus that might be in your car. On that RVC bus is the battery management system, the Firefly, the alternator charger, and then a tie-in to the Victron Cerbo. Victron Cerbo screen is the lower screen, and the Victron has its own proprietary bus. They call it the VE bus, and that controls the inverter and the solar charger. But the Victron Cerbo, ties all the systems together for complete control. Okay, let's dig into the Firefly control. So, first of all, the touchscreen is connected over the RVC communications bus so that it kind of ties in with everything else in the van. There is under the rear seats in the box and kind of the front of the box is what's called the G12 panel. The G12 panel, it kind of includes the electronics for the Firefly. So when you're turning lights on and off, or water pump on and off, what that's actually doing is switching an output on that G12 panel. So this is just the user interface. So from the home screen, you have some basic light controls, some information on your tanks, water pump on and off. You can turn the inverter on and off through the Firefly awning extension and retract. The Starlink button, just so you know, from the factory, it doesn't really do anything. It's not wired to do anything. This is something optional that you could wire up or have someone wire up to Starlink for you, so that you could turn just the Starlink on and off independently. From the factory, as long as the two Starlink power cords are plugged into the receptacles behind the rear seat, Starlink will be on whenever the inverter's on. Want to look first at the settings screen on the Firefly just to make sure that everything is set up right. Check your version. This is version 14.7. If you're running an older version, you might want to consider upgrading that. You can reach out to Firefly and they can email you the new firmware and the instructions on how to do the upgrade. Most important thing on the settings is that your floor plan is set to SY. If it's not, you're going to need to change that, and I'm going to show you how to get into the hidden menu to change the floor plan and a couple other things. So you hold down the floor plan for a few seconds, and it gets you into this kind of extra setup screen where you can choose the correct model. Should be set to SY. Under main options, these are the settings that you should have enabled. It should look just like this. Under electrical options, you'll want to make sure the Go Power controllers are set to 0. So it should say controllers 0. That's an important one. Lithionics batteries should be selected. Progressive inverter should be selected. That gives you the button on the home screen to turn the inverter on and off. And AES enables the automatic engine start for charging. And that's also an option that does not come from the factory. You would need to install the high idle and remote start kit for Mid-City Engineering. And once that's installed, you can enable AES, and we'll dig in a minute to see what that looks like. The cabling to connect that high idle kit is actually pre-installed from the factory. So it goes from the G12 panel under the seats. And the cables are kind of coiled up behind the dashboard, sort of under or behind the steering column. And when you install the Mid-City high idle kit, you would then come in and enable AES. And when you do so, you get a new menu for auto engine start settings. We'll dig into that in a moment. The lighting panel, just a couple quick tips on this one. Um, when you turn on a light, you can push and hold, if there's an up-down arrow, you can push and hold it to dim. So you can dim each light, kind of set up a scene that you like. So if you turned on a couple of different lights, when you hit the light master off, it remembers that scene. It knows exactly which lights you left on and how they were dimmed. So when you turn it on, it comes back exactly the way you left it. The exterior works exactly the same way. That's kind of handy. If you want to just sort of zero out all those settings and have everything on, if you push and hold on, clears it all out and everything turns on. The climate controls are just for the AC unit in the back. Let's go ahead and dig into the auto engine start. Okay, once this is all set up with the Mid-City engineering kit, you get into this menu, and when you want to charge the batteries, you can set it to automatically start the engine based on a certain threshold. So I'm going to enable auto engine start, and it walks you through some warnings because, of course, you don't want this to start on its own when it's parked in a garage or in some kind of unsafe space. So you want to be really careful with enabling auto engine start. Once you're in here, you can set the threshold. So if the battery is, say, at 15% for more than a minute, it'll start and run the engine for up to, say, 115 minutes. And you could set quiet times and that sort of thing. And once that's all set up, it will, in fact, automatically start the engine when it reaches the threshold. I don't use it that way. I use it a bit more manually to start it up to charge the batteries. If my batteries are low, say down to 20%, and I run the high idle to charge, they're fully charged in under an hour, maybe 45 minutes or so, and it works really well. So to do that, you just go in here, you push start. It's going to take a second. And there we go. The motor has started. It has now gone up to 1500 RPM. And momentarily, it takes a few seconds, but momentarily that second alternator is going to kick in. Takes about 30 seconds or so. It'll kick in and apply a full charge. That's a 5,000 watt alternator, so it's going to charge the batteries really quickly. That's a lot of power. And there we go. So the alternator's kicked in, and it's right now it's taking 4,600 watts and rising. If you'd set up AES, you could have it automatically turn off when it reaches a threshold. That could be handy. Tells you the engine is running. I can just hit stop, and it's going to turn off the engine. And there we go. Engine stopped and is no longer running. Okay, one more quick tip here is you can get into the battery details, and it's going to tell you how much time it thinks it has left for runtime. So it says that at the current power load, which at the moment is pretty low, I just have a few things turned on, Starlink and some lights. At the current power load, it thinks it has about 37 hours of runtime left, and that can be pretty convenient to kind of check and see how much runtime you've got. If I turned on a large electrical load, so this will be the heating element for the heater, something you wouldn't normally do unless you were plugged in. But running off a battery, turning on the heating element is a pretty big discharge. So you can see the time remaining has dropped to about 4 hours and 20 minutes, and that'll continuously update. Couple more things that could be handy to know about in the settings screen. You can look at network diagnostics. That ties to the G12 unit that actually switches power. It also receives the switch commands. So there's some light switches. There's a water pump switch in the back, for example, that it receives commands from. So if you get into network diagnostics and look first at the devices, it shows all the inputs. So these are the switches, for example. If I reach up and grab the switch to turn on the overhead light here over the bench, you could see that number 2 briefly turns green. And that's just indicating that I'm pushing that switch in. If you look at the outputs, it's going to tell you what's currently active. So I have some exterior lights turned on. Those are green. If I turn on the bench light, that one turns green. And this is just a useful place if you need to do some troubleshooting to see what's going on with your system. The other thing to know about here is setting up the mobile app. There is a mobile app I'd recommend you download. It's the Mira app. You can use the QR code to download it, and this is where you'd find the ID and the PIN to link to the mobile app. The mobile app really gives you all the same controls that you would find right here on the touchscreen onto your mobile device. It's just Bluetooth, so it's within probably 20 feet or so of the van. But it can be pretty convenient if you're outside and you want to turn lights on, or if you're in bed and you want to switch something. Okay, let's dig into the Victron controls. This is the touchscreen that runs a device called a Cerbo. The Cerbo is kind of the brains of the entire electrical system here. It ties all of the electrical devices, including the battery, all together. And the touchscreen is pretty darn useful for doing a lot of things. First of all, let's take a look at the controls across the bottom. It's got a briefing screen where it looks at power coming in, battery and water levels, power going out. You can extend that with a little more info on the right-hand side. It tells you what's going on with your solar, for example. I find this overview screen here to be the most useful screen. This is where I leave it by default, because it really tells you everything that you want to know in one place. So on the left-hand side are your sources. So you've got shore power, and by the way, that yours might say grid. You can change that. I'll show you where later. But my shore power is disconnected. My solar yield right now about 90 watts. My inverter charger is on and inverting. This is my battery level. Tells me it's discharging. Tells me how much time I have left on the runtime. And on the right-hand side, it tells me what's going on with my AC loads and my DC loads. So my AC loads are coming from the inverter. If the inverter's on, you've got some AC loads. The DC loads are lights and water pump and kind of everything else related to the van. If you're trying to conserve energy, you want to reduce these numbers as much as possible, so it's pretty useful having it on screen. A quick note, if your screen does not look like this, you're running older firmware, and I strongly recommend you update to the latest firmware. I'll leave a link in the description below on how to update the firmware, but it's pretty easy. You'll connect the unit over Wi-Fi to the internet, and once it's connected, it's as easy as a button push to kind of switch the whole thing over. One other note, and I'm not going to get into all the detail right now, but if yours is showing amps instead of watts, so W is watts, A is amps. If it's showing amps, switch it over to watts. Amps is not a real useful way to look at actual power loads because it's going to depend on what the voltage is. So short version, leave it on watts. That's the most useful way for you to know what's going on. Any device that has a blue outline means you can interact with it in some way. So, for example, if I touch the inverter, it brings up the inverter controls, tells me that the inverter is on. If I was charging, it tells me what kind of connection I've made. If I was plugged in, at a campground, if I was plugged into my house, we'll look at that in a minute. Um, Same thing on the solar. You can even get into graphs. If you want to look at the history of your solar, you can see some graphs that are kind of useful to give you an indication how that's going. You can dive into your battery, look at battery temperatures, the state of charge, the state of health, how much runtime is left, that kind of thing. And then for the thing you're going to change most is setting up, controlling the inverter. And as I mentioned, you can touch the inverter to do that. I think it's a little easier to push this icon in the top left of the screen. This is where you can simply turn the inverter on, off, or set the mode. I think there's only two modes here that are useful. On means that you'll have power coming out of the AC outlets for coffee maker or to cook or using Starlink, that kind of thing. It also means that if you happen to be plugged into shore power, it will simultaneously charge the battery. Charger only turns off the AC outlets and will only charge the battery. Um, the way that I operate is when I want to use the AC outlets, I go to on, and when I don't want to use them, I just go to charger only. I think that those are the only two actually useful modes. Um, Regarding charging, if you're plugged in at a campground on that big 30 amp receptacle, you're going to leave the shore current limit set to 30 amps. That's going to be the fastest way to charge your battery. At home, you run the possibility of popping a circuit breaker on your home breaker panel because you may be trying to draw more current than your 15 amp home circuit is capable of. So if you're plugged in at home, what I'd recommend you do is bump this down to 15 amps. And if that's still tripping your breaker, maybe even bump it down to 10 amps if you had to. I run it at 15 when I'm plugged in at home, and it works fine. Remember to switch it back to 30 at the campground. It'll just charge a little faster when you're plugged into a 30 amp circuit. Let's see. The next button is levels. It's telling you about tank levels, your water and gray tank. If you have extra phantom tanks showing up, if you have LPG or black water tanks showing up, it means that your Firefly has outdated firmware. That's what causes that issue, and you have to update the Firefly. It's not actually a Victron issue. One kind of neat thing I've done is I have purchased these little tiny Bluetooth sensors. They're temperature sensors and they're wireless. I have one in the van and I have one outside to give me the outdoor temperature. I just popped that up on the roof in the best shaded spot I could find. And then for the interior, it tells me the interior temperature and humidity. And I find this to be much more accurate than the temperature sensors that come with the van. Finally, under settings, your screen may look a little different depending on the version of firmware that you're running, but you should have access to all of the same settings. You just might have to dig for them a little bit harder. So in settings, you can see all of the devices that are connected over the RVC bus or the VE bus. So the tanks, the temperature sensors, which are Bluetooth, uh, your battery, your solar charger, really all of the devices that make up the electrical system. And there's generally, you can change some settings here, but there's not much that you would want to change. For example, under the battery settings, you can dig in and look at the temperature, the health of the battery. But the device and parameter settings, you're going to want to leave those in the default, and I'm going to let you take a quick look at them just in case you run into any issues on your system. By the way, the charge current limit and charge voltage limit, that's actually coming from the battery management system. So the Lithionics battery says, hey, right now I want to charge at 57.6 volts, and you can go ahead and give me up to 165 amps. And that goes out on the bus and tells the alternator, or tells the inverter charger to charge at that limit. And as that battery, gets to full, or maybe it gets over temperature or under temperature, it's going to reduce those thresholds to keep the battery safe. This is one of the great things about the system, is if the battery's approaching full, it says, no, I don't want 165 amps anymore. I just want 3 amps to top it off. These numbers will in fact change. That'll be communicated out to all of the charging devices to keep the battery safe and to ensure long life with the battery. One important setting to be aware of under system setup is the charge control. That's distributed voltage and current control. You want to make sure that that's always enabled. That allows the Lithionics BMS to control the charge voltage and charge current across all the devices on the bus. It is possible to override the maximum charge voltage. I haven't actually tried that to see how it works, but the most important thing here is to make sure that DVCC is always enabled and that the Lithionics battery is set as the controlling device. You can get into Wi-Fi and connect to Wi-Fi. That's important if you want to update the firmware, but it's also required to use the remote management tool called VRM. We will look at that in a minute. This is also where the RVC bus and the VE bus get set up. You don't want to change them, but I'm going to let you take a look at mine so you know how they're supposed to be set up. So the CAN bus profile needs to be set to a battery management system. And the VE CAN port needs to be set to RVC at 250 kilobits a second. Those are going to be the most important settings to ensure that all the devices can communicate properly. VRM, this is something I would recommend using and setting up. So you'll need your VRM portal ID so that you can log in the first time. And just make sure that VRM is enabled. Under general settings, this is where you can update the firmware. So I'm running a beta version of firmware, but I would recommend, you can run the beta. I've had no issues with it at all, or you can just run the latest release. The trick is to connect to Wi-Fi. You go to online updates, you press to check, it'll say update available, and you push the update. Takes maybe 5 minutes. It goes pretty quickly. One thing that I think is kind of important, I mentioned this earlier, is to make sure you're looking at power in watts. So that would be under general, and you scroll down to display units, and you want to make sure that your electrical power display is set to watts and not amps. If you don't like the label of grid for the shore power and prefer that it be called shore power, that can be done under System Setup, AC System, AC Input 1, and you can switch the name here. So I do want to show you the Victron VRM portal online. It's pretty cool because you can be away from the van, and as long as the servo is on, which means the main battery has to be on, as long as the servo's on and it has Wi-Fi, and that Wi-Fi could even be through the Starlink if you wanted, you can access it and control it remotely over the web. So you'll set up your account at vrm.victronenergy.com, and once you do, you're going to be able to connect and see a status screen that shows you the state of the battery, the various loads that are enabled, the time to go, how much runtime is left with the battery. You can turn the inverter on and off. Now, be cautioned, if you're using Starlink for your connection, you turn the inverter off, you'll lose your connection, of course. If you have the Ruuvitag temperature probes, it'll even tell you the interior and exterior temperature of the van. You can get into some advanced settings and look at all kinds of pretty interesting charts. You know, the state of the battery charge over time, how much power you've been using over time. You can customize this quite a bit. You can look at the solar charge as well, and you can even get in and look at the temperatures of the interior of the van over time. One of the other great things you can do is open this remote console. It takes a moment to load, and when it does, it's essentially remote control of the Victron screen. So you can see everything you'd see just the same way as if you're in person in the van. You can get to all the setup menus. I can look at the temperature probes. I can look at all the settings, any alarms that might be going on. I find this to be a really useful tool if I'm trying to track something down, especially over time, or change a setting remotely. There's a version of VRM that you can load as an app on your phone as well. Okay, so these are the apps that I use most often. So the Lithionics battery app is a real important one. Connects over Bluetooth, tells you the current state of charge of the battery, tells you if you're charging or discharging. The red numbers indicate that I'm discharging, and it's telling me how many watts in total being used. If it was charging, those numbers would go green and tell you how many watts in total are being charged. Time remaining, if it's red, that's kind of a countdown. I have 4 days and 11 hours of time remaining. If the battery were charging, this would go green, and it would tell you how much time is left to charge. Status code is just a way to look at various status alarms from the battery. If any of these turn red, that status code would go red as well. The next screen dives into some kind of deeper state of health information from the battery, and the last screen tells you the individual cell voltages, and you can see how well balanced this battery is. They're all exactly the same, which is amazing. Occasionally they get a little bit off, but they tend to balance themselves out again pretty well. Another app I use quite often is Victron Connect. This uses Bluetooth to connect to some of the Victron components in the van. It's going to scan real quick and find everything that it can. I wouldn't worry much about connecting to the Cerbo GX with this app. There's really nothing to see, nothing to do. I was in VRM. I'm going to go to local. It's going to show me the battery protect units and the solar charger. There are some important settings in both of those, so we're going to take a look. Starting with the solar charger, it's going to immediately show me the status of the charger, how much power is being generated. But the little gear icon lets me set up a couple things. And I have seen where these have been misconfigured, so let's take a look at some important settings. Your battery voltage needs to be set to 48 volts. That's the voltage of the lithium system. Of course, charging should be enabled. The rotary switch should be set to position 7, and the BMS control should be set to yes. Now at this point, it's all set up correctly so that the Lithionics battery management system will control the solar charger. Let's look also at the two battery protect units. And we're going to get into this some more in a minute when we look at the electrical diagram, but I do want to show you where you can see the voltage of the 12-volt system. So here we show about 12.9 volts on the 12-volt side of things. I want to show you where to adjust the shutdown voltage if you had to. So the little gear icon, you can see I have mine set to shut down at 12.2 volts and restart at 12.5. You can experiment with this a little bit if you have issues I think it comes from the factory at 12.5 volt shutdown, or maybe 12.4. If you have issues with the system shutting off when it shouldn't be shutting off on the 12 volt side, you can adjust this down a little bit. So this is a simplified electrical diagram of the van. The sources for power are on the left, the battery system in the middle, and the outputs are on the right. The big double lines, big double red lines, are the 48 volt system. So let's start there. We have the battery in the middle. It's connected to the battery management system, and the output of that battery management system goes on to a 48 volt bus. That bus ties together the 48 volt alternator, the inverter charger, the solar charger, and then it feeds out as well to the air conditioner and two DC to DC converters. The purpose of these DC-DC converters is to take 48 volts and convert that down to 12 volts to feed the 12 volt systems. One important point to mention on the solar system is you only want to turn this switch on and off when the battery is on, when there's power on that bus. Because if you turn the solar on, or if you accidentally leave the solar on and shut off the battery, the solar just doesn't have enough power to power everything on that 48 volt bus. And you're going to get some beeping and low volt alarms, and you're going to know that something's wrong, and it's likely just that you forgot to turn off the solar switch. So it's best to only operate the switch when the battery is turned on. When you're plugged into shore power, that shore power input goes through a split breaker panel. One bus of that breaker panel is just for feeding the inverter charger, at which point this becomes a charger, and it is putting 48 volts onto this bus and is charging the battery through the battery management system. When you're not plugged into shore power and the battery is powering the 48 volt bus, this becomes an inverter and creates 110 volts to put onto the other half of that breaker panel to feed your 120 volt receptacles. On the right hand side, want to talk about what's going on with the 12 volt system, and I think that this is pretty important to understand. So 48 volts is converted to 12 volts. The 12 volt bus feeds two battery protect switches. These are automatic switches that turn off if the voltage becomes low. One of the switches feeds the 12 volt fuse box, and kind of from there, goes to the fridge and the bed lift and the toilet and the 12 volt systems. Also feeds the Firefly G12 to run things like lights and the water pump and the awning. The other battery protect switch feeds what I call an essential bus. This bus is intended to just kind of be on all the time, and it feeds the step lights and the clock and the battery heater and a couple of other things. The idea is that your main power switch here by the entry door is going to switch just this battery protect switch. So it's going to turn on and off the sort of the master 12 volt power in the van. This other battery protect switch is on all the time unless the voltage drops down too low. The other kind of interesting thing here to note is that the chassis electrical system, so this is the Mercedes AGM battery to start the engine, it goes through a switch that's accessible in the back of the van. And that switch is also feeding this 12 volt bus. So when you turn off the main power and this switch turns off, now the van chassis battery is feeding the entire 12 volt bus. Good and bad. It's kind of a backup. It means that you could, in fact, with the lithium battery turned off. You could push the main power button and run the 12-volt systems in the van, which is kind of handy. Um, Unless you push the button here to disconnect this switch. If you disconnect this switch, the batteries are no longer tied together. Um, the purpose of tying these systems together is so that your chassis battery never goes dead, right? Anytime the lithium battery is turned on, these DC to DC converters are making 12 volts and keeping this battery charged. You could even start the engine off of the lithium battery this way, as long as the switch is on. Now, if you push this blue button and the switch is off, you've completely disconnected these systems from each other. For long-term storage, it might be a good idea to push this button and disconnect the systems, but otherwise I just leave them connected at all times. It works pretty well. The communications are indicated with blue lines. This is the RVC communications network. And then the magenta lines are the VE control. And all of that goes back to the Cerbo. The Cerbo ties it all together and makes sure that all the systems communicate and coordinate as one.